Hi, my name is Julia, and I'm a student at Georgia Tech, and this is Lab 1 Constant Velocity for Physics 2211. So, what I'm going to be talking about today is an introduction on what we're doing for Lab 1 Constant Velocity, and then we're going to do a motion analysis, a representation of the computational model, and then we're going to graph what we used, and then we are going to look over some additional questions. So the formulas we used was the position update formula for a constant force, which is the position final vector is equal to the position initial vector plus the velocity initial vector times delta t plus 1/2 the net force vector over mass times delta t squared. But because there's zero outside force, we can drop the net force vector, and so we get position final vector is equal to the position initial vector plus the velocity initial vector times delta t. So for motion analysis, I analyzed a marker rolling on the ground. So we used tracker, and we rolled the marker and then set it up next to a meter stick so it would be able to figure out how long it was rolling and the distance. And then we analyzed it frame by frame to figure out how fast it was going. And then our computational model, we used Conan GlowScript, and I set the ball's initial position equal to the vector 0, 0, 0, and then the ball velocity is equal to the vector 0.00540, and then 0, 0, because I took the first second of motion for my observed marker, and that was the x-coordinate of the motion, how far it traveled. So I could use that as an estimate to figure out how far it would travel later. So for the applying the momentum principle, I put ball velocity as ball velocity because I wanted my ball velocity to be the vector shown above, and then my ball position is equal to the ball position plus ball velocity because of the position update formula. So this is my predicted versus observed graph. The blue line is what I predicted the marker to roll, and then the red line is actually how the marker rolled. So if you see that the predicted marker went further than the actual observed marker. So some questions on that is, why weren't the predicted and the observed the same? Well, that could be we neglected air resistance and we neglected friction, and we rolled it on like a carpet, so friction would play a part in that. It wasn't a frictionless surface. So with the next question, is the net force 0? No, the net force isn't 0. We neglected things that obviously would have affected it, and if I go back, you can see it did affect it. It is going slower, and you can kind of see how 1 point's under the line, 1 point's over the line, 1 point's under the line. Like, that line isn't straight either, so it is definitely not a 0 net force. And then what would happen if we change the x direction to the negative x direction? It would basically make, if I go back to this graph again, it would basically invert the graph, and so all the velocities would be going down, the distance would be going farther away from the origin. So it would be kind of like if we take, the velocities would still be going faster, or no, not the velocities would still be going faster. The distance would be going farther away from the origin, but it would be like if I took this graph and put it in quadrant 4 and had all the slopes going down instead of up. So, thank you.